have worked with Redux? Redux, yes. Okay. How many of you have worked with Redux middleware? Smaller number. How many of you have built your own Redux middleware? Just 3. I have something to show you guys. So, hi, my name is Abhinav. I am a web engineer. I am the only Abinav that I know that doesn't have a H in his name. So if you're searching for me, search with ABI, please. Thank you. So I am Abhinav Seelan at Twitter, GitHub, and I also run a blog called Camp Vanilla with Alti, who's here in the audience. We write about JavaScript stuff every now and then, web dev stuff, and stuff that we usually see on a daily basis. Like for example, we wrote an article about documentation. So if you guys are interested about stuff, you can check us out. We don't write that frequently, but from time to time. I also am a web engineer at this place called Hashnode, if you can see that, hashnode.com. So we build a Q&A network for developers. So it kind of makes sense for this meetup here. So it is a platform where you can join in and be amongst a friendly community, ask questions, have discussions, and the likes. You can also ask questions to big open source contributors. So we had an AMA with Redux community, for example, quite recently. And also, we are the official discussion platform for React. It's in the React documentation. So, if you have any questions regarding React, visit Hashnode. Okay. I also have stickers, about 25. So it's like a first come, first serve thing. So run to the stable once this talk is done. That being said, now to the juice of it. So I know half of you guys said that you knew Redux or have worked with it. So I'll run you guys through a refresher, and for the remaining, maybe run you through what Redux is. And thank you, Kiran, for kind of introducing everyone to Redux. It's still a necessary part to React applications. Maybe GraphQL is the future, but let's see. So that being said, so Redux at the crux of it is just a state management library. Why you would need one is when you have large-scale React applications, and next thing you know, you have these tiny little tidbits of state running in each component, and then you're like, where is something happening? Why is it happening? Redux was sort of the solution to all of this. So Redux had these 3 very opinionated core principles, which kind of made it what it is today. So what Redux said was, hey, you have this React application or an Angular or Vue application, and instead of you having your state, kind of flying around the place with it being in each component, how about you move it to a single source of truth? So what Redux said was, hey, I will give you a store, okay, this huge JavaScript object where you move all your state to, and you can pretty much look at this as your single source of truth for your entire application. The second one is that this single source of truth is not modifiable directly, which is different because if you work with React, you can just do like set state anywhere you want. Here it's a little bit more cumbersome. So the way, or actually, you know what, the way you use set state to change the state in a React application, Redux asks you to dispatch something called actions. So you use a method called dispatch to send an action, which is basically a proposal as to what you want the store to change to. And the final thing is that you have this object, you have proposals, how do you piece these two together? That happens through these pure functions called reducers. So you have this entire block of code that would sit in between your dispatch event and your final store that defines, given your current state of your application and this proposed change, what do I do to make the new change? Okay, and since it's a pure function, whatever state existed before this action was dispatched is no longer there. You would always get a new version of the state that you have to kind of work with. So to kind of paint a picture of all these terms, this is Redux in a nutshell. So you would have your Vue, which could be your React application, Angular, Vue, whatever. It would send out actions. That, you know what, I propose to do this to this state. So let's say, we can keep this as a running example. Let's say we have a to-do application. We add to-dos, we remove to-dos, and the likes. So an action would be like, here, I want to add a to-do to this list of to-dos that I have. So I would take that action and dispatch it to this big store object. Okay, that dispatch method goes to this reducer, which is this pure function that knows now what I want to, what the change I want to make is, takes the previous state of the store and then performs some computation. So in an add to do setup, it's like adding it to none, right? And then returns a new state of the store, which will immediately trigger changes or notifications to the view, saying that, hey, the store has changed, do what you want with it, but the store has changed and I'm just letting you know, okay? So the reason why Redux makes a lot of sense for React developers is because it just works really well with it. You just tell it that, you know what, something's changed, it just triggers a rerun immediately. But yeah, it's just a notification sent to the view and the view handles it accordingly. So yeah, so to kind of put all of this into perspective, I have this, if you guys can see, there's a small demo project that you can kind of play around with. I'll sort of code along with you guys, kind of running through how a store is quickly built, right? So let's see, move this. Okay, tell me when to stop, because I don't know if I should stop. Yeah. This one works?
Yes.
Okay. Right. Okay. So Redux is not a part of React, which is something that hit me much later. It's its own thing, and it is its own library. You can import it as a standalone entity. So one thing that we need to import for creating a store is the create store method from Redux, right? And const store is create store, and you're done. Okay, but we are sort of missing out on two key things, which is that a store needs that reducer that I was talking about, and it also needs some sort of initial state, right? Like, how does it know what my object is? I need to tell it that, you know what, this is my initial state and this is where you have to start from. So let's just create a couple of things. So I have a function reducer, right? Which doesn't do anything now, but it's just a function. And we have an initial state, which, can you turn this light off? I can't see half the screen. Sorry. One press key there. I'll just do this. I'm sorry for blocking a couple of people.
There's the screen.
No, I can see. So again, running an example, we have a to-do application. So we have a list of to-dos, right? Which would just be another. And now when I create the store, I have to pass in this pure function. So now I'm actually encapsulating it within the store and also pass in the initial state, right? So now I can run this very simple toy application that I built. Right. So it doesn't show much, but DevTools is where everything happens. So if I refresh this, nothing happens, okay? And that's because we have to do the last bit, which is the fact that we need to subscribe to the store, right? We built it, it has this reducer, it has the initial state, but it's not connected to anything. It's its own standalone thing. So to subscribe to a store, it's as simple as, okay, so store.subscribe, okay, which is a function that will trigger every single time the store changes, right? Like I said, anytime there's a change in the store, it automatically notifies the view being this little toy application that I have here. So it's going to throw out a simple console log that says that, hey, your store has changed, and that's what I'm just notifying you. And to trigger this change, we need to dispatch actions, right? So actions are proposals, they hit the store and they trigger changes to the view. Trigger changes to the store which notifies the view. So to dispatch an action, it's another method that is within the store. Dispatch. Okay. And an action is like, I said it's a proposal, right? So it's nothing but an object which has a key called type. So for example, add to do, right? and let's just like dispatch this a couple of times. So I do it twice, for example. Now when I go and refresh the page, there we go. Okay, there we go, right here. So it tells us that hey, the store's changed. So now when we go back here and dispatch this a couple of more times, 4 times this time, we get 4 notifications. Okay? So every single time an action is dispatched, the reducer handles this and throws out a notification saying that you know what, the store has changed. But if I go in here and I have a method called getState in my store, which will tell me what the state of my store is at this given point in time, you will notice that it's undefined. Okay? Even though I actually gave it a initial state. Where did everything go? Okay, and that happens because the reducer is a pure function that what takes the state, takes the proposal, returns a new state. Our function is not doing anything, right? So let's just like fix that. So we come in here. I can't see my function. So if, for example, my action, so the reducer, if you look at the slides, it takes in the state and it also takes in the action, right? So it takes in the state, takes in the action, okay, and it would, at this point, let's just return the state. Okay, so it's just a function, takes in the state, returns it. We come back here and refresh. You get the to-dos again. So now we're building this pure function, we're actually building on top of this. So now let's actually do something with this. So it's a proposal with the state will define what needs to be done, right? So this is where the logic goes. So if my action dot type, which is what I'm dispatching here, is, for example, add to-do. Okay, I'm going to push into my state dot to-dos dot push of learning Redux and Middleware. And then I return the state. I'm building this again. So this is sort of how the entire flow happens. You subscribe to the store to see changes to your view. You dispatch actions which will trigger, which will go to the reducer. Reducer has the logic to combine the previous state, the new proposal, and spit out a new state. So you can see that the to-do array is actually increasing with each time. There's more stuff you can actually do with the action. So let's say right now I'm just pushing this learning Redux thing, right? What if I want to actually push some more value? So you can actually send in more keys with your action, which allows you to kind of send more data along with this dispatch action. So let's say this has something called a payload and has the to-do, and say, okay, this is to-do 1. Okay, and I copy this over to that, and that. Okay, and here it's, for example, the second to-do. The next one is maybe like buy milk. Last one is like get some sleep. Okay, so I have these payloads that are going in with the action, right? So here I can, instead of doing this, push in the action dot payload dot to. Okay, and now when I come here, the same thing happens. So Chrome does this thing where it computes the object that's collapsed on the fly. So I'll just actually subscribe to this directly. So here, so I have to-do 1, now to-do 1, to-do 2, then buy milk, and everything's being pushed one by one as each action is being dispatched, right? So now that we're sending in some actual data, there's one mistake we're making here. So remember how I said that it's supposed to be a pure function. So the key aspect of a pure function is do not mutate your values. So whatever function parameters go in, you don't mutate it. But that's exactly what I'm doing here. So even though it works, it's frowned upon. Like it's kind of you going against the Redux, like the Redux way of things in a way. So what I can do is set up a new state, which is initially equal to the state. Okay, and whenever I have to add a new to-do, I also reassign the previous to-dos. State.todos.slice. So I get a completely new copy of the to-dos, and instead of pushing it to state.todos, I'll push it to the new to-dos now. So now I'm pushing it to a completely new copy of the to-dos array. So action.payload.to-do, and finally new state is a completely new object. Assign the previous, so it's a completely new object which is initially empty. I'm sending in all the values of the current state, and I'm overriding the to-dos array with the new to-dos array. Okay, and finally, instead of returning the previous state, I will return the new state.
If you're doing that, then line 6 would be useless, right?
Where is line 6? Not entirely. Well, I'm sorry, I have to. Yeah. Okay, so let's say I dispatch an action that is like not handled by my reducer. Okay, so doing this will basically tell the final catch, like after the reducers go through and it has to apply it to the store, then you know nothing has changed. This is the exact same state that you sent back in, so don't change it.
But aren't you handling that in object.assign the second one, it will reassign?
Okay, so I'll run it this way. So what you would run through one, maybe multiple reducers, okay? And finally, when it has to apply it to the store, it actually goes back into Redux's control. Here, if you actually look at the Redux source code, it checks for a flag called has changed. And the way it determines this has changed flag is by seeing a diff with your previous state and a new state, okay, in terms of keys. While ideally, just sending down new state would like show you the same keys as before. This is like you just taking the same reference as state and sending the same reference back. So in a way, when it's calculating the diff, it would just be like, hey, nothing has changed at all. It's the same state that went in before. So this has changed is false. Don't do anything to the store. It's just like a fail-safe. Ideally, you're right. I could just put a final catch-all and just reassign a new state with object or assign to state, and then send that down. But I mean, this is just a way for you to keep the previous reference. So if nothing in between has handled it, the reference is not changed. I'm still pointing to the previous state because that's what's happening here, right? I'm just copying the reference over. So, where was that? Oh yeah. So then I return the new state. And if we go back here and refresh, it pretty much does the same. Okay, except now you're being as true to Redux's principles as possible. So now that, and this is like a tidbit for those who haven't worked with Redux, you see these two values, right? Or specifically this value here. An action can have anything. Okay, it's just an object that you dispatch, you handle it in the reducer how you want. But one thing that is 100% mandatory, do not forget to do this, is the fact that an action has to have type. Okay, it's the only key that's mandatory in the action. Anything else is like, you can name it whatever you want. So for example, here if I go and change the type to command, right, and come back here and refresh, Redux is going to tell you that, hey, actions may not have an undefined type property. Have you misspelled or that? Some other error message, but basically you're missing the type key from this action that's being called here. So if I go back here and change, let's say, payload, which is it's my defined key, to data, it's going to be more than happy because the type is the only required mandatory key that we need in Redux. Okay, just cementing that in there. So yeah, this is pretty much how you would kind of work with Redux as like just Redux. Okay, so whatever you see here in code is pretty much it's pretty much this, right? So that being said, where does a middleware fit in? Okay, now coming to the actual juice of it. A middleware sits right between the dispatch function and the final reducer. Okay. So anytime you dispatch an action, the middleware actually sits between where it's coming from and where it actually has to go, which is the reducer. Okay. And I mean, just keep a note of the arrows, but you can see that the middleware gets a hold of the action, gets a hold of the state as well, and also has a pointer to the reducer, or at least a means to get to the reducer. Just keep this in mind. So, what does the middleware encode? It's this triple curry monstrosity. So it's a function that takes the store, right? Returns a function that takes in the next function, which I'll get to in a bit, which then returns a function which takes the action that's being dispatched. Okay, triple curry. And for those who don't know what a curried function is, like meet me later. But coming to what the next function is, what the next function here is a means for an action that has been caught by the middleware to go to the next middleware if you have multiple, or if this is the last middleware, for it to go to the reducer. Okay, extremely crucial. But that next function is what, like, once you enter this function, it means to leave this function and go to whatever needs to handle it later. Okay, but this is pretty messy to write like on a daily basis. So if you ES6 this thing, it actually looks much neater. Okay, so I have a middleware called awesome middleware. Takes the store, takes the next, takes the action in 3 different functions, and then you do something with the store and action. And like I said, once I'm done with everything, call next with the action so that it can continue on its execution. How many of you guys have worked with Express.js? Just show of hands. Okay. Have you guys seen this before? Okay. It's pretty much how an Express.js middleware works. Okay. Yeah, at the end of the day. Okay. It takes a request object, takes a response object, takes the next. Okay. You do something with the request, you do something with the response. Once you're done, call next. Okay. I do not know if Dan Abinov and Andrew Clark had actually based Redux's middleware on this, or it was just like a happy coincidence. They just met up one day. They're like, "Oh, you do the same thing." I have no idea, but it's basically the exact same thing. Okay. And if you've actually built an Express middleware before, you would feel right at home. And another question that I had when I first started out, like looking into this, and what a lot of people had is, why is there so much curry? Okay, so I'll give you a TLDR, too long didn't read type answer to this. So the way apply middleware, which is a function we get to at some point, where you actually apply this middleware, the way this function works is let's think of it this way. So it applies the store, the first argument of this, separately, then composes all your array of middleware separately, and for it to be able to do this in 2 different places at 2 different times is the reason why they would like you to have them as 3 different functions that just return each other. If you just had state, I mean, if you just had one function that takes store, next, and action as 3 parameters, it's harder for the implementation of applying middleware to kind of break these 3 things down. So that is the TLDR version. The TLDR version. There is a detailed explanation here. I'll send you guys this slides on meetup.com. But the documentation has a pretty detailed explanation as to why this happens. And if you're the adventurous type, you can actually look at the source code. I have the exact line where this thing happened. Okay. So that being said, let's finally build a middleware, right? So we are going to build something damn simple. So it is going to be an error logging middleware. So anytime my action.type contains the string error, okay, or my action.payload contains a key call error, okay, which is usually the 2 ways you would handle an error. If these 2 are present, I want you to log this, okay, a simple error logging middleware. So we know what the structure of a middleware is. So let's say just before we create the store, we have error logger, which is our fancy new middleware. It takes in the store, which returns a function that takes in the next, which returns a function that takes in the action that's being dispatched, and finally, we need to do something, right? So now, let's handle the first case. So if my action.payload has a key call error, I want you to log it. So if action.payload.error, I'm just checking the existence of the key. Then console.log and error. I spelled upward. So now let's create some actions that actually do this. So the first one, send in 2 send in 2. Let's say the third dispatch action, the buy milk one, has an extra key called error. Oops, they were okay. So my action dot. I want to change this. Load. So now I have four dispatch events that are happening. The third one in particular has an error key. Okay. So when I go back to my console and refresh, you see that nothing has happened. Okay. That's because we have built the middleware, but we haven't actually applied it. So the same way how we didn't apply the reducer and the initial state when we built the create store, there's another argument that has to go in, which is the actual middleware, because you have to encapsulate it within the store object. So now here, to do that, you need one extra thing from the Redux library, which is apply middleware, which is what I was talking about in the cutting section. So once I have my built middleware, I have to apply it. And the reason why I'm passing this into another function is because these arguments can be one, it can be many. You can have a string of middleware that you want to run through. So you just need to compose all of these. So apply middleware handles that. Returns basically a composed version of all these middleware in middleware. And when I create the store, I have to pass that in. Well, right? So come back here, refresh the page, and suddenly my store events are no longer triggering. Okay, I can see that my error has been logged, but my store events aren't triggering. Okay, and this is why you should never forget the next. Because what's happened is every time an action is dispatched, it goes through my error logger. Okay, because it's between the reducer. But since I didn't call next, it was never actually forwarded to the reducer. It just stopped there. So when the third dispatch went in, yes, it logged it, but still didn't go to the reducer. So calling next of the action will forward it on. So when I come back here, there we go. The first store change because there's no error. Second store change, no error. Third store change first went through the middleware, logged the error, and then goes to the actual thing, makes the change. Okay, and then the fourth one. So now that handled one of the cases I was talking about. Let's also add another case, which is if my let's see, error is in my action.type. So if my action.type contains add to do underscore error or like remove to do underscore error. So anything that has the word error in it, I'm just doing a regex test here, and I'm checking if the action.type has that. So let's convert another action to do this. So let's say the third one also error because we clearly don't sleep anymore. So that one has add to do error. So now when I come back here, there we go. We have an error that was actually triggered for the third dispatch event, and we have another error that was logged for the fourth. Okay. So now this is a very trivial situation, right? Like, why would you want to log your errors to the console? Makes no sense. Okay, but let's say this goes out into the wild. You're in a production environment, and you want to catch errors that are being. You want to handle errors. You could have an error logging library, but you could theoretically also build your own. Okay, so anytime you know what your subset of error types are, in the sense, if I have an error, I would dispatch a thing with the word error in it, or I would have the payload have error. If I know that, I can just handle it right here, right? But now, what I'm doing right now is just telling the user that an error has occurred. I want more details because if I'm going to log this on the, in a logging mechanism, I want more details. So now, since we have the store and the action at our disposal, we can do some more stuff. So let's say I want to know what action actually triggered this. So console.log, the action that triggered this was action. Okay, and I also want to know the state of the store when this error actually happened. So we know that store.getState is a function, and we have access to store. So the store when this happened is store.getState. Okay, and just to sort of pretty print this, let's do console.do middleware error console.do and middleware. Okay. So now again back to the dev tools, we can see that we have a more in-depth analysis of what, where it was triggered, what triggered it, which is the action, and what the action was carrying, and also the state of my store when this happened. So let's say a very weird edge case happens when my store looks like this and this action is being dispatched. I can have complete control over what I see on my error logging mechanism. And in like full-fledged middleware, what I would do is basically take this entire console log block, send it to the server. Okay, whatever my logging mechanism is. So yeah, and within 10 lines, we've actually got a pretty useful middleware up and running. Pretty straightforward, pretty easy to work with. So what are some use cases? I mean, this again, like I said, was a very trivial example, but one pretty nice use case that I had come across while like getting this together is analytics. So is anyone from Swiggy here? No? Okay. Let's say I have a food delivery startup, and it's called Jiggy for all intents and purposes. And I am on a restaurant, okay? And I know that I've built my application in such a way that if I want to jump from one restaurant to another restaurant, I need to dispatch an action. So get new restaurant details and I move, and then on the view. And I want to track this, okay? You can actually write a simple middleware. And you know what? If the action is of, move restaurant, I can capture the previous state, capture the action that's happening, and then send this to a server. And I have like full-fledged analytics detail. And I don't need to like download a separate analytics library like Google Analytics or like Hotjar or whatever. I can just like tell again within very minimal lines of code, build your own for your own use case. Loading animation is another simple thing. So anytime any action with the phrase request or start or something of the sort comes in, throw up a quick loading animation on the DOM, and then the subsequent end or success comes in, close the loading animation. Stop actions before it reaches the reducer. This is a very nice use case where, let's say, someone here had a discussion about moving to GraphQL, right? So let's say you're moving to GraphQL today. I'm sorry, I'm using you as an example, but let's say I'm moving to GraphQL today, and I want to slowly do this incrementally, okay? And I want to start deprecating actions. And I have this huge enterprise application. I have this action being dispatched from numerous places. I don't want to just go do a command shift F, find it and remove it, because I don't know what the implications are going to be. But I do know that I don't want my store to change if this action is dispatched. Okay? So a simple thing, 10 lines of code, put it in there and be like, okay, if this action belongs to an array of deprecated actions, just don't call next. Okay? And next thing you know, your Redux part is being phased out and your fancy new GraphQL thing is being set in. That's another use case. Another one is like syncing state. So let's say every time you trigger an action, you want the client to have the most updated version, but you also want to save this state somewhere in your local storage on the server, so that if he comes back or like leaves the tab or something, you want the state to always be there somewhere. So again, catch it in the middleware and sync it with the server. Okay, and then just call next, and then you can have the client change, but all the previous states just stored on the server. So yeah, that's about it. I wrote a quick blog post yesterday detailing everything that I just spoke about.
Also help for authentication.
Which one?
Authentication.
Of course. So let's say you dispatch an action and you need to be authorized for this. One thing you can do is every single place that you have, let's say a dashboard. All routes in your dashboard, I would have to check if this .props. Let's say user details.id exists, then take him here. Otherwise, reroute him to login. What you can do is have that logic written in your middleware okay, and either do window.location and move them elsewhere, or you could like set a flag and have all components just read that flag. So that is like, again, single source of truth. If your authentication fails for some routes, you know where it's happening in the middleware. Yeah, but like I said, I've written an article about this. So if something went over and then you went back and read about it, you can always just go check.